Hello guys, today we are going to talk about two sample proportion test. So what we want to do is we want to test whether the two proportions are the same or not when we have a two contingents table that we have today here. Unfortunately, as of April 17, 2020, USA is has the largest number of deaths from COVID-19 in the world, and Italy is the second largest death occur. So this table shows the number of people who died from the COVID-19 and the number of people who has been recovered from the COVID-19, and all of the numbers in here recorded in thousands. So we have 36 for USA, which means we have 36,000 people who has been died from COVID-19, and we have 59,000 people who has been recovered from the COVID-19. So which means 36 plus 59 makes the 95. So we have 95,000 observations from the USA. And for Italy, we have 22,000 people for number of deaths, and we have 42,000 people who has been recovered from the COVID-19 in Italy. So we have 64,000 people observations from Italy. So the total number of observation we have here is 159,000. Okay. So our goal is to compare that let's say P1 is the death rate of COVID-19 in USA, and P2 same in Italy. And we want to test that H null is P1 is equal to P2 versus H alternative is P1 is not equal to P2. Okay, we don't know what is the exact death rate of the COVID-19, but we assume that if there exists a true proportion of the death rate of the COVID-19, then that should be same both country. Okay, but there is a possibility that these two rates are different because of the maybe countries the way of dealing with the COVID-19 in between the countries become they could be different. So that could be a reason that maybe death rate of the COVID-19 between the countries are different. Okay? So we already set up our hypothesis, and the next step for the proportion testing is estimate the P. So P1 is the death rate of COVID-19 in USA. So what I'm gonna do to estimate the P1, I'm gonna count the number of people who already died, so number of deaths in USA, divide by the total observation, number of observations in USA. So in here we have 36,000 divided by we have 95,000 observation, but these are cancelled, right? So if you calculate this, I get 0.3789. Okay, and for P2, which is the death rate estimate of the death rate of COVID-19 in Italy, is the we have 22 and the observation number is 64,000. So this makes 0.3437. Okay? So we have P1 hat and P2 hat. Okay, and next step, so this is the step 1, and next step is calculate the standard error. Okay, under the null hypothesis. So next step is calculate SE under the null hypothesis. So what does this mean? So we have learned that standard deviation of difference between the proportion P1, let's say P1, and P2 can be calculated by this formula. So P1, 1 minus P1 divided by N1, and N1 is the number of observation for group 1. So observations in USA in our context, plus P2, 1 minus P2 divided by N2. So this is the standard deviation of P1 hat, P2 hat. Okay. However, what we are assuming is that under the null hypothesis, in here we are assuming that P1 and P2 are the same. And let's say this one we have like P naught. So I will just call P naught is equal to P1 and P2. Then, what I mean is that this one and this one are P1 and this ones are P2. But when we assume these twos are the same, we can grab this and then take away from the this fractional form. So what I mean by that is that we can rewrite this formula into this form. Okay. So P1 minus P divided by N1 plus P1 minus P divided by N2, and this part are same, so I can write it down this formula like this: 1 plus N2 when we assume that H null is the true statement. Okay, so since we are assuming that H null is true, we can rewrite this formula like this. Okay, so since we want to use this one to our standard error, so what we need to do is we need to estimate the P, because we don't know what is the P, right? So to estimate the P, we need to use the older information we can access to, right? So the P is the death rate of COVID-19. So in the denominator part, we should use the number of people who died from COVID-19. So number of death and number of observation. And when we think about the number of death, we have this is the 36, like the number of death in USA, plus 22, which is the number of death in Italy. Okay, so this is the 58 And the number of observation we have here is that we observed 95,000 people from USA, and we have 64,000 people from Italy. So we have in total 159,000 people. So our p hat is 0.3647. Okay. So what I want to do, I want to use this number to estimate this p. Okay. So my final answer for SE is this number, 0.3647 multiplied by 1 minus 3647, and then 1 minus 95,000. Just be careful, our observation are recorded in thousands, so we have actually 95,000 people in the USA, and then 64,000 from Italy. So if you calculate this, our SE is actually really small, which is 0.000246. So the third step is calculate the test statistic. And our test statistic is z-test statistic, and this one can be calculated by p1 hat minus p2 hat, subtract 0, divide by SE, and this is E we have just calculated in the previous step. So we have p1 hat and p2 hat in the first step, right? So we have p1, we have 0.3789 for p1 hat, and we have 0.3437 for p2 hat. So I will just plug in that number into here. So my p hat was 0.3789 minus 0.34375, and I don't want to write down 0 here, so I will just omit that, and then we have 0.000246, and if you calculate this, you will get 14.29835 something. Okay, so now we have calculated the z-test statistic, and after the statistic, what we want to do is we want to calculate the p-value. Okay, and this p-value varies, become different. This p-value could have a different form depending on your alternative hypothesis. And let's say, let me just pull up the material I can use here. So let's say our alternative hypothesis looks like this, like something is less than p naught and something is less than p naught, and maybe so in the kind of test we can have in the basic statistics, all of them, either the first form or second form or third form. I mean, all the alternative hypothesis looks like this one and this one or this one, right? And depending on these form, your p-value could be calculated by this. And this one is g is less than small z, and this one is 2 times p large z larger than small z. Okay, and this small z is the test statistic value. Test statistic, which is this number that we have calculated. So since our alternative hypothesis looks like this form, right? Because we are testing P1 and P2, whether the P1 and P2s are the same, and our alternative hypothesis looks like P1 and P2 looks like this, like P1 is not equal to P2. So my alternative hypothesis looks like the third form, right? This one. So my p-value can be calculated by this way. And this one is 2 times probability that standard normal distribution is larger than absolute value of z, and I know that z is 14.29, so this is like 14.3. Okay, and when we think about the standard normal distribution, it's a symmetrical distribution centered at 0, and one standard deviation is 1. So when we think about the 14, it's way far away from the center. So this probability itself is really small, like something like 0.0001. So even if I multiply it by, even if I double it up, this whole thing is way smaller than 0.0001. Okay. So maybe my final step can be like compare p-value with your alpha, which is significant level. So if your alpha is larger than p-value, then you can reject H null. Otherwise, maybe p-value is larger than alpha, then you cannot reject H null. And in our case, since our p-value is way smaller, it's really small. Even if I set my significance level like 0.0001, I can reject my H null. And what does that mean? That means we have statistically enough evidence that we can say the death rate of COVID-19 in both countries are not the same. Okay, does it make sense? Okay, so this is for today for the two sample proportion test. Okay, let's just do the two sample proportion test in Sas. Okay. Now I'm going to use the actual COVID-19 data, which I grabbed from the website. So April 17, 2020, in USA, we had 36,922 people has been died from COVID-19. And in Italy, we have 22,745 people has been died from COVID-19, which is so sad. So we said our hypothesis looks like this, and to load the data, what I want to do is just copy and paste this code in Sas. Okay. Okay, first line of the Sas code means I declare my data set name as COVID-19, and I knows that I'm gonna input for the country, and my second column will be death or recovered. So I just named it my second variable as status, and third variable is count. So first data entry looks like this. We saw the observation from USA, and its status is death, and we have 36,922 people in this category, and we have 59,000 people for the recovered category, and so as the Italy, right? So we have this number, this many people in death category data, and we have this one for the recovered category. And if we submit this one, and then we can see Sas can recognize data without any error. And to confirm that, I can just use proc print data is equal to COVID-19 and run. Then I can see my data is there in the system. And to do the two sample proportion test is actually really simple. Where is that? Simple code. So let me just copy and paste here. So we're gonna use the frequency procedure, and I set COVID-19 as my data for the procedure frequency procedure, and we're gonna use count for the weight, which means when they calculate the table, they divide, they use the count, how can I say? They automatically they automatically choose the count variable and then calculate the total number. So you can think like this: when you use the frequency procedure in Sas, they will make a table using country and status. Okay, looks like the table that I put in my website. Exactly looks like this. So Sas will makes this table when you enter this frequency procedure and then declare, hey, I want to make a table, and one of the variables in that table will be country, and then one of the variable in that table will be the status. So this is two-way contingency table, and we ask stat in the cell it should use the count variable. So when you submit this one, you can actually you can see, where is that? You can see this table. Okay, let me reference result create. Let me just do it again. So if I submit that now, okay, now I have this table, right? So in Sas, it will actually generate the two-way contingency table, and then we have frequency, and then this number, second number, represent the percentage. So what does this mean? So this means like 14.08 means 22,745 this group, like this whole group, takes the 14% of the total observation. So when we think about our total observation is 161,552 people. In like we observed this much of people from both country, and this one group, like that in Italy, takes the 14% of the whole group. Okay, so my point is Sas will generate this two-way contingency table for you, and then it will show you the this table too. So risk difference test in Sas, in our code we actually put this option, risk difference, and we assume that the risk is equal, which means the same. I think this risk difference means in Sas it will think the risk as a proportion. So when they have risk keywords, it means that they are referring the proportion thing. So risk difference is actually proportion difference, and then we are assuming that they are equal. So which means risk difference equal means we are doing the two sample proportion, assuming that the both proportions are the equal. Okay, so that's why it will give you this risk difference test table, and in here we have this z-test statistic number, which is -15, and our two-side test p-value is less than 0.0001, which is so small, so we can sure that we can reject the null hypothesis, which is p1 and p2s are equal. Okay, so this is p1 minus p2 is equal to 0, means p1 and p2s are equal, right? So we can reject the null hypothesis based on the result from the Sas. Okay?